situations where you can use the cylindrical method for calculating volumes of revolution. And I'm pretty much going to pick one of each to do. I might pick two in some situations. But if you have a single curve of the form y equals f of x, and you rotate it about the y-axis, this is the formula called the shell method that allows you to get its volume. Again, rotating about the y-axis, but this time it's the area between two curves. Then this is going to be the formula for the volume using the cylindrical shell method. And one of the interesting things about it is that although you're rotating about the y-axis, all the information is in x's. That's important, obviously. Now, if you now rotate things about the x-axis, like a single curve, the formula looks very similar, but do you notice it's now got everything with y's? So although you're rotating about the x-axis, it'll be 2 pi y times whatever f of y is, right? So f of y might be sine y or y squared plus 1, right? But it'll be a function x equals y squared, x equals sine y, whatever it might be. And the limits of integration are from the start value of y, c, to the end value of d. And the last permutation is, I guess I could put a little extra dotted line in here, whatever, is when you're looking for the area between, say, two curves, it's 2 pi y, just like this guy, but y's. Now, when you are doing an area between two curves that's being rotated, either about the y-axis here or the x here, you do have a decision about who goes first and who goes second, right? Is it this function first, take away the other one, or do you switch places? Now, when you are rotating about the y-axis, your little rectangle is parallel to the y-axis. In other words, it goes up and down. And in this case here, can you see that the f of x is higher and the straight line, the g of x, is lower? So, I don't know what to call it, high and low. Work. The high one, the low one, right? That's how you tell. On the other hand, if you're rotating about the x-axis, your little line looks like that. It goes parallel to the x-axis. And in this case, can you see that the f of y is the one that's furthest to the right, and the other one is to the left? So that's f of y, and this guy over here is your g of y. And that's pretty much the only decision that you need to make as far as which formula to use and the orientation of f and g. I think I've mentioned this, but it's worth mentioning again. Suppose you get it back to front. Suppose you do these two guys, but subtract them the other way. What will you notice about your answer to the volume of the shape? Instead of doing them in the right order, you accidentally picked the opposite order. What would happen to the value of the volume that you would get?
Would it be negative?
It would be negative. And not only would it be negative, as long as you did all the math right, it would be negative the same number. So if the volume was 20, you'd get minus 20. The volume was, if it was minus 8, you got, the volume would be 8. Now that's very helpful when you're doing your homework, because some of these questions might take 15 minutes. And if the only thing you did wrong was go, oops, right? Then wouldn't it be easy just to go into the box and WebAssign and say 14 instead of negative 14, and just say to yourself, okay, don't do that again, right? But you don't want to have to redo the whole question for that. Now that is provided you did everything else correctly, right? If you did all the algebra, all the integration, and so on, that's pretty much an easy one to fix. Now, if you screw up in the algebra somewhere, you may end up with a negative answer. You may end up with a positive answer. It'll just be wrong. And that's a little bit harder, because don't you have to just go through the whole question and say, darn it, I dropped the 2x here. Or that +4 should be a -4, whatever it is. And in those cases, you kind of have to do it again because the number is going to be different, right? And you can't really predict what the number is when you do some kind of algebra mistake. So let's start the ball rolling, and I'm going to call, I guess I'll call these number 1, number 2, situation 3, and situation 4. So situation 1 is going to be a single curve rotated about the y-axis. So who am I picking? I'm picking this guy. The curve is y equals x cubed. There's going to be a y equals 0, a y equals 1, and check this guy, and then x equals something not right about that. Now it's right. X equals 1, x equals 2. I was scanning somewhere weird. Right. I could certainly do that in Desmos, but it's not a curve that is that difficult to draw. Are you comfortable with that's what y equals x cubed looks like? You've probably seen it lots of times before. Now, they've got a couple of other things added on. X equals 1 would be here. X equals 2 would say be here. And the guy called y equals 0 is basically the x-axis. So what they have done is told me the single curve, right, that we are going to rotate about the y-axis. Well, the volume is in terms of x's, so it's from A to B, so that's from 1 to 2. 2 pi x times x cubed, because that's what f of x is, right? Dx. Are we okay so far? 2 pi x, f of x. Right, make it look pretty. Pull out that pi, which I probably should have done earlier. We're going to get that guy. Not the worst integral in the world, would you agree? When you get to this stage here, it doesn't matter where the question came from. Isn't it just, I want to integrate something and do all the usual tricks of the trade that you need? This one's just a power rule, but can you imagine you might have a U sub to do, you know, in some questions. And maybe you've got a trig thing you have to deal with, you know, like sine of 2x or whatever. That can work. Okay, so what we have here is add 1 to the power and divide by the new power. Evaluated at 1 and at 2. First guy, 2 away, second guy. Plug into 2/5 times 2 to the power of 5. If you plug in 1 there, you just get 2/5. 2, 4, 8, 16, 32, 64/5. Take away 2/5. And I believe that is 62/5 pi. We are finished. If you rotate this shape about the y-axis, the volume of that shape will be 62/5 pi. Let's see if I can predict what it might look like. Put a little dotted line down here. A guy that looks something like this. Probably make a little image, something like this. And then you try and imagine a big circular version of that. What on earth would that look like? Some weird modern art piece of, you know, artwork that costs $50,000 and you look at it and you think it's not worth $5. That's what it reminds me of, right? It's just a, can you imagine, it's like, it just goes like this. Weird looking shit. If that hole was there, at least you could have a bowl or an ashtray if it wasn't a hole in it. Oh, I just thought of what it looks like. It looks like a medieval mace to me. And you stick the piece of wood in the middle and you could batter people over the head with it. One between two curves. There's so few questions, I don't really want to use them up, so let's make up my own. So this is situation 2. And I'm going to have a curve y equals 2x plus 1. And you can't see what I'm doing right now, but I'll show you what I'm doing in a few minutes. I'm putting this into Desmos. Right, that looks good. Nice straight line. Let's have an x squared on the next one. And let's see what that looks like. Okay. And we're going to do it from x equals 0. Yeah, I want that. Let me tweak this a little bit. Will that work better? Keep tweaking. Eventually I'll get this to turn into something I do like. Right, here we go. I am going to mute everybody so we don't hear someone private conversation. I'm almost done here. I'm trying to figure out a good combination and not being very successful right now. Oh, perfect. There we go.
The screen isn't shared for us yet.
I shall now do it for you. Right, so here is the area between these two curves, and we're going to rotate it about the y-axis. And I've already done the Desmos part of this. So basically, y equals x squared looks like this, which I'm pretty sure you would be able to do without Desmos. And y equals 2x looks like this. And so the area between the two is the boat shape, right? So far, so good. Now, if I want to find what does this look like when it's rotated about the y-axis, the general formula is the integral from a to b, 2 pi x, then in brackets f of x take away g of x dx. Well, I can pretty much tell you that guy's 0. If you use Desmos, you can find out that guy's 2. So that's me got the start and finish. Stick the pi outside. I've got 2x. Now, since I'm rotating about the y-axis, wouldn't it be a good idea to put a vertical line just like the y-axis? That way, can't we tell who goes first, which is the straight line, and who goes second, which is x squared? So that tells me f of x and g of x. So the highest one was the straight line, and the one lower down was the curve. Okay, where do we go next? Let's change this light, maybe it'll help. There we go. I need to integrate this. Algebraically, what should I do to make that possible?
Multiply everything together.
Okay.
Though you're not going to like the answer to this one.
Oh God, it's not 8/3 again, is it?
It may or may not be 8/3.
Oh, well, there are only so many simple questions you can make up, so I'm just going to live with it. Yeah, it does have a kind of familiarity to it. You plug into, what do you get? 2, 4, 8, you get 32 thirds. You plug in 2 here, you get take away 8 minus a whole load of stuff. That's 24 thirds. Yes, it's my friend 8 thirds again. I may even have done that question. If not, I certainly did one similar to it.
Yeah, we did do this question, I think, yesterday.
Yeah.
Practice is nice, though.
It's good to see it. It's really just a process. So can you imagine the next time that might be x cubed, right? And that might be, 2x plus 1. But won't the only difference be 2x plus 1 goes here, take away x cubed? It won't look that different. So it's still a good template question that you can use to go through that. So who else have we got left? See. Done that. Have I done this fella? I definitely did it with my evening class. I remember this one. But have I done this one with you lot? Does that look familiar?
I don't think we've ever had an XY before.
Okay, so this is going to be situation 3. So this is the first one today where we're going to rotate something about the x-axis. Now, to save some time, I'm going to kind of draw what that guy looks like. Now, if you want to write what that guy looks like, you can certainly type it in. It looks like that. Now, how do I get from there to there? Don't I just divide both sides by x? Which means that you get a really ugly curve that looks like that. And I'm going to just call this curve xy equals 3 for the time being. Now, what we got to work with here is y equals 3, which is say about here. And y equals 5, let's say it's about here. And x equals 0 is basically the y-axis. So here is the guy that is going to be rotated about the x-axis, right? Now, it's basically just a single curve about the x-axis. We have a formula for getting the volume. It's the integral from c to d, 2 pi y, f of y, dy. Well, I know the y values are from 3 to 5, so that's where they came from. And now I've got f of y to work with. This curve has to be written down as a function of y. This curve was originally written that way. I changed it into that format just so it was easy for me to sketch. But the version I am going to use is this version. Essentially, x equals an f of y. To see that you have to rearrange the equation of the curve to suit the form that it needs to be. I need this curve to be a function of y, which means that this fella becomes that guy. Now, something quite nice has happened to this integral. Don't they cancel out and you're just left with a number? That's very rare. I think that's the first time we've ever done that, right? Mostly you get something left over, right? There's just coincidence. It's not typical. Power row. Evaluated at y equals 3 to y equals 5. Plug in 5, you get 30. Take away, plug in 3, you get 18. And the answer, 12 pi. You like that one? Could have been worse. I think I've done, well, let me rewind that. This is another example of that same kind of question, right? So this is still situation 3. And this time, and it's still going to be rotated about the x-axis. Does that look familiar or is this new? Anybody get any, I think I've seen this before, or nope, don't know what this one is? No
I don't
recollections.
remember doing a question like this.
Okay, sounds good to me. So, going to take this guy, and we're going to, well, I should be popping it into Desmos, and I'm going to do that right now. And I'll show you me doing that because I've been just telling you lately, this is what it looks like when you do it in Desmos, but can't keep doing that forever. So it's going to be, I'll bring this up. So it's going to be y equals x to the power of, and 3/2. So I should be able to just go 3 divided by 2. Perfect. And nothing that special will make this go away. Just a curve, right? And particularly unusual about it. We had some other things to do. We have a y equals 8, which is this blue line going that way. Okay, done that. And we have an x equals 0, which, by the way, is the y-axis. So can you see that the shape that is going to be rotated about the x-axis is this shape here, right? So I'm doing a little baby version of it so that when I return, we can see what we're working with. Okay. So that was basically that's what Desmos was to do, you know, because you can't always draw something because you know what it looks like, right? You're going to have to do some Desmos work occasionally. So that's the guy we had. It starts at 0 and finishes at 8. So I know that it's 0 to 8. I know it's going to be 2 pi y. And it technically should be f of y dy. So I'm going to have to do a little, put it in red, I'm going to have to do some algebra here. That guy is y written as a function of x. What I want is x equals a function of y, right? That's what I need. Because whatever is where my finger is what goes there, right? So we have to get from this piece of information and rearrange it so it looks like this guy. Now I have a rule, which I love, called as long as you do it to both sides, it's okay rule. So I am going to do something to both sides here, and I'm going to take it slowly. I am going to square both sides. Are you happy about 3/2 when you square it gets you 3, and y squared gets you y squared, obviously. Now, what do you think I'm going to do to both sides to get an x?
Cube root.
Going to do a cube root. And isn't the cube root of y squared also called y to the 2/3? Are you happy about how this became that? The algebra that I used to make it happen. So we are going to be putting that guy there. So this becomes, pull out my pi, 2, this guy times this guy gets you y to the power of 5/3. Right, 1 plus 2/3, 1 2/3, 5/3. Now, power rule. Add 1 to the power, yikes, 8/3. Dividing by 8/3 is the same as multiplying by 3/8. 3/8 times 2, you get 3/4. And it's going to go from y equals 0 to y equals 8. Eight to the power of 8/3, take away nothing. I know this is a nice number, so I'm just going to let the calculator do it for me. So here goes, 3/4 times 8 to the power of, put a little bracket around it for safety, 8/3. Answer, 192. So 192 pi is the volume of this shape, oops, when you rotate it about the x-axis. It would probably look something like this. I have no idea how to describe that shape, but that's what it would be. Not all shapes look like something familiar to me. Okay, that is situation 3 done. We have one last situation to do, and I'm going to make this one up. That's going to be situation 4, better put my formula handy, where we are going to take two curves, right, the area between two curves, and rotate it about the x-axis. And I'm going to go over here to Desmos and practice. Okay, that looks good. I like that one. Okay, that looks interesting. And I know you have to be patient here. I'm just playing about with shapes to make something work. That looks good. So this question is x equals y squared plus 2, x equals 2y plus 2, and it's going to be rotated about the x-axis. So here is one that I prepared earlier. And this better not be equal to 8/3. Now, if I move this around a little bit, I can even make it a little bit bigger. Can you see the banana boat shape, which is quite common for these questions? The red one is the parabola shape, and the 2y plus 2 is a blue straight line. So I have a shape that looks something like this. And the straight line is x equals 2y plus 2, and the parabola is x equals y squared plus 2. Okay. Now, the point where the shape starts is 2, you agree? but isn't the y value 0? And when you rotate about the x-axis, isn't it the y coordinate of that point? I click on it. Isn't it the y coordinate of that point that's important? Not with the x's, just the y. And if I click on this guy, do you see it's 6, 2? I don't care about the 6, but I do care about the 2. Right, I think I've got everything I need from that picture. So I'm going to return now. We are going to look at this fella here, which is basically what I just drew. And the volume between, the volume that you get rotating here is the integral from C to D, 0 to 2, 2 pi y. Now, since I am rotating about the x-axis, don't we use horizontal lines parallel to the x-axis? And we're looking for who goes first, right? F of y. Take away who goes second. In this picture, straight line or curve, who goes first?
The straight line goes first.
Right, agreed. Furthest to the right goes first. Take away the other guy, which happens to be that fella. I'll pull out the pi, and it's 2y. This fella here is 2y plus 2. Take away a y squared, take away a 2. The 2's very nicely cancel out. Looking good? Right. Would you agree that I need to distribute the 2y and hope I don't get 8/3 again? Power rule. That's not good. That is not good at all. Plug into 2, 4, 8, 32/3. Take away 8. Oh, guess who's came back to visit? Eight-thirds. I think what you're going to pick out of this lesson is totally wrong. Hey, if you're doing one of these questions and you don't know what the answer is, pick 8/3 pi. You might get lucky. It might be the right answer. There is no reason in the world except I'm very bad at randomly picking guys. I'm trying to make ones that join up nice, and I think when you do that, you just kind of fall into the trap of 2s and 4s and y squareds and things, and those guys just seem to combine very nicely. And that means we have finished cylindrical shells.